Yeah, so move the 9x. That's the theme for the entire quiz, is get everything on one side. So we want to leave the x squared. We want to move the 9x into the center as a minus, and then root the minus 10. Make sure your terms are in order. That could be really would be really catastrophic if you didn't get that. So x squared, then x, then number. And so since we're factoring, this isn't an ABC concern. This is one of these. So I know it starts like this. Tell me about my signs. For sure, one of each. You can just pencil those in, and then you just start running through numbers that multiply to make 10. You don't have a lot of options. Yeah. 10 and 1, right? And since we need it net to come out -9, we're going to put the beefy 10 with the minus and put the wimpy 1 with the plus. And then it balances correctly. You always want to check it. Somehow I say these words and some people I don't know how this doesn't work. Here it goes. Check them. If you're not sure, check them. Just always multiply these together. You get 1x. Multiply these together. You get -10x. They add to make this. You've done well. So then the answers to the equation are what? That's it. So we just write x equals a number, comma, x equals a number. That's that. So you'll have about 4 or 5 or 6 problems of just that to start the quiz. Right? I don't know. I haven't written it yet. I'll write it tonight while I'm sitting there chilling, hanging out with the dog. Still have one dog. What do we do? Move everything to one side. So y squared plus y minus 12. Make sure you keep your equals 0. That's what separates this from being just a factoring problem to being a solving problem. So we know it breaks into this. Tell me about my signs. One of each, because they multiply to make -12. Then what do they have to be? Yeah, bless you. We know 2 and 6 aren't going to work. We know 1 and 12 aren't going to work, because we think about the balance, and when we add the 2 green things, the connector things, then they got to make 1. And the only way that's going to work is if we give it a 4 and a 3 like this. Bless you. And you check it. 4y in the middle, -3y on the edge. Got it. So what are the solutions? Good. All right, so we'll dispense with the simplicity step. Got a few more of those, but really at this point, you get the idea. Like, you just get it equal to 0 and you do your thing. So you remember that when factoring gets harder is when we place a number in front of the x squared, like this. And unless I make a typo, I'm not going to mess with you and like toy with your emotions here. If I ask you to do it by factoring, I'll make sure that you can factor it. There's not going to be like any trick questions unless and again, if I make an error when I'm typing them in. So I'm not going to ask you, you know what to do. We're going to move everything to the left because that's where x squared will be positive. So 4x squared plus 15x minus 4. So the difficulty goes significantly up here because there's more than one way now to make the front. And so as soon as you introduce a number into the front, it's like, it gets harder. And the 4 is troublesome for us because what we don't know going in is, should we do this? Or should we do this? You've been down this road before, so and there's really not a magic trick to it. You can watch all sorts of YouTube videos, and everyone thinks they have the best way. You just do it. Like, you just make it work. I mean, where there's a will, there's a way. It's just not rocket science. And so there's a hint in the middle. The 15 is a hint because 15 is really close to 16, and 4 times 4 is 16. So the more you practice, you start to realize, you go big brain mode on these, and you think, if I think hard about this, if I put a 4 here, it powers with this 4 to make 16. And then if I put a 1 here, 16 and 1 make 15, right? Because we're going to have one positive and one negative. So you start to it's not an arbitrary game. You don't just guess. You know what I mean? Okay. So then we want the plus on the big beefy 16, and we want the minus on the little wimpy 1. And there's your 16 minus 1 for 15. Easy peasy. So what are the solutions? And that's it. Questions there? Okay. What are we thinking here? That's a 28, actually. Sorry. My handwriting just took a dip there. I'll do better. So 28 equals 15x minus 2x squared. What should we do? Yeah. And we're moving everything to the left, not because we have an affinity for the left side. We're doing it specifically because we want that x squared to go positive, right? So everything is going to the west side. So we're going to have 2x squared. Then what? Mm-hmm. And we should like this problem more than the last one for multiple reasons. The first reason is this, that when I build my binomial factors, my shells, I don't wonder if it's going to look like this. I know it's going to look like this because choose a prime number, and it's the only way to make it is 2x and 1x. And I also like it because there's not one of each. If they multiply to make positive 28, they can't be one of each. They specifically have to both be minuses. And then you just quick run through the list of numbers that make 28. I think we can rule out 28 and 1. That would be pretty dumb. 2 and 14, we really probably want to gravitate more towards the center ones, the 4 and the 7. So the question now is, so I'm going to mess up on purpose and just show you that I hope I mess up on purpose. Yeah, so if I put like the 7 here and the 4 here, it's not going to work, right? Like I know it makes 28, but it doesn't work because these make -4 and these make -14. But the lesson that we've learned over the years is that that doesn't mean that 4 and 7 don't work. What does it mean? Got it backwards. They're the right numbers potentially, but in the wrong place. So 4 and 7, you don't throw them out. You just say, let me try switching you dorks, because you're gonna behave differently if I put you in different places. So now the 2 in the middle make -7, and the 2 on the outside make -8. Ah, jackpot. So what are my solutions?
X equals 7 half.
Good. So I'm not going to do any more factoring problems right now unless you really want me to. I mean, that's what the first half, not half, it's not proportionally accurate, but the first part of the test is going to look like is just here's some equations, factor. You have to factor. Okay. All right. So this last bit is going to be just all quadratic formula, and I've got a ton of these written. I don't realistically think we have time to do all of them, but let's see how much we can accomplish here. So this section now you must use the quadratic formula. Even if it turns out it was factorable, if you use the wrong method, you get 0 points. There's going to come a point where I won't boss you around. I'll be like, solve it however you want to solve it, but not now. But the initial expectation doesn't change. What do we do first? Yeah, move everything to one side. Set it equal to 0. That's just not going to be something that we don't want you to do. So I'm going to move the 3x over to the left, and that's going to, the 4x squared is going to stay. What's my x going to be? Minus x. Good. So we transition now into the point where we don't want to try to factor it. We just aren't going to do that. We're not even going to think about it. We're just going to say A equals
4,
B equals
4,
-1 and C is okay. So I'll give you about a minute here to start working this out, and then I'll wait and I'll put mine up on the board and we can compare. if I assume you're going to prepare a page of notes. Maybe that's what you're working on right now. But I also assume that the quadratic formula will be on your page of notes. That would be pretty weird if it wasn't. So I'll write that much and then I'll stop. Yeah, it's not day one, so I'm not going to be like sweet and supportive if you make any mistakes to this point. I just can't for the life of me think of any reason why anything could go wrong. We've had our discussions. I've lectured some of you about the fact that this number, I'm going to point to it with a yellow arrow, is always positive, right? We also know this one, I'll point to it with a green arrow, is always the opposite of B. If it's negative, we make it positive. If it's positive, we make it negative. Those are just things we can't miss those. We can't. And now we got to do some math. So at this point, there's always 100% of the time something that I expect you to think about. What is it? It's not mathy really per se. What is it? Where's my brain have to go right now? Yeah, but before that, I just need one big break me open thought. What is it? If I haven't made this clear, I need to ask myself if the minus sign that's in front of the 4 is going to stay as a minus. People that are good at this, you'll know what I mean. That's all I want to know right now is that minus going to stay as a minus or is it going to switch to a plus? It's going to switch to a plus. What some people do once they acknowledge that it's going to switch to a plus is they go through with their pencil and they actually just go tick, tick, and they just change them. And it's like, okay, out of mind now. I'm not going to worry about it anymore. I realize now it's just one big dumb addition problem. That's got to be thought one once you get done with the dumb part, the blue part. Thought one is, do I switch the minus or keep it? Thought two now is, I got to do some basic math. Calculator or no calculator, I don't imagine that you quite frankly need it. But the next thing you do is you multiply the numbers in this green box together. It's just not, there's not like, oh, I do it a different, nope, there, you just do it this way. What is 4 times 4? 16 times 2. What's 1 plus 32? And that is what it is. The process will never change. So it's 1 plus or minus the square root of 33 over 8. This is nice. This is the kind of math that we should really like because it's just you do it the same every time. That's nice. And so now my next thought, I don't mean to be like the thought police here, but I considered the minus, I switched it to plus, I did the math in the green box. What's my next thought? Is it reducible? Is it simplifiable? Can I do anything with the root? It's the only thing right now that I care about. Tell me about the root of 33. It's dead. Right. So what about 3 and 11? And I'll tell you they're trash. 3 and 11, yay, but they're do us no good if they're not rootable. So this is what you put a box around. And this is probably your favorite type of problem because even though it's kind of butt ugly, you like it because there's no more work to do. That's nice. Done. Any questions about that? I'm going to try to give you a sampler platter here today of the different things that can happen. So there's one thing that could happen. I didn't really intend to write this problem this way. Looking at it now, I kind of think that's pretty dumb, but whatever. What would we do? Yeah, and actually, I think I'd probably combine them and move them. Since we're not like first week of algebra 1, I think we can handle this. So I'm going to leave the 2x squared alone. I am going to combine the minus 4x and the plus 3x to make what? Minus x. And then when I move them, they are going to become plus x. That was a little wonky. Sorry about that. Any questions so far? So same drill as before. I'm going to write down with you that a is 2 and that b is 1 and that c is negative 15. And then I'm going to wait now. I'm going to pause, and you're going to take a moment and write as far as you want to go. And then I'll write what I think it is, and we'll compare here in a moment. Good. So let's compare, make sure we all got to the same place. Can't think of any reason why we wouldn't show this step. Just there it is. And so where does my brain go now? Do I change the minus in front of the 4, or do I keep it? I change it because that 15's like, I'm coming in whether you like it or not. I'm going to hit that minus 4 eventually. So let's just get this done now. And let's just turn the whole thing into one big dumb addition problem. There. Done. Don't have to worry about that. And now what do? You multiply only the 3 numbers in the green box together, right? Leave the number in front out for a while. What's 4 times 2? What's 8 times 15? What's 1 plus 120? Very good. So the next thing that I probably would write would be negative 1 plus or minus the square root of just a number, 121. So I wanted to make sure we got a little bit of this in today's review too, because something spectacularly unique is about to happen. What is it? It can be square rooted. So this is a different flavor completely, and it will happen. And so what is the square root of 121? It's nice. You don't even have a root, like the root's gone. So when we proceed with these, we get what are called rational solutions. That means that there's no like root 2's or stuff like that. So it's just x equals negative 1 plus or minus normal 11, like third grade 11 over 4. And now what do? It's not the answer.
Yeah, you know, like the pathway.
The pathways, right? And so you have to you choose. Most people, normal people, do the plus pathway first. With rational solutions, you're not allowed to stop. The thing with math is you've heard me say this before, we go till we run out of stuff to do. That's what simplifying is all about. So I can do more math. I can trace the plus pathway. I'll circle plus in green, and here we go. Forgetting the minus sign, what's negative 1 plus 11? So one of my answers is 10 over 4, which reduces to 5 over 2. 5 halves. That's an answer. The other answer is produced by the other pathway. I'll circle it in yellow. Forget the plus, do the minus. What's negative 1 minus 11? So one of my answers is negative 12 over 4. And what is that? Negative 3. So the way you'd want to present this, since I get to grade this and we want to be courteous, is you now want to present your answer formally and say, here are my answers. X equals 5 halves or X equals negative 3. That's what you put a box around. That's the polite way to present an answer. Still good? Okay. Can I scroll? May I scroll? All right. I'm not exactly sure now what some of these are going to be. I just started writing them down and just kind of caught fire. So let's see where this one takes us. Don't know. This will be a surprise for everybody, including me. What's going to go after the minus 6x? Good job. You put 5 there. I'm sending you to Mr. Dishman's office with a nasty gram stapled to your shirt. All right, so we subtracted 3. Woo! What's A? What's B? What is C? Nice. As before, I'll give you a moment. I'm gonna scroll a little bit because I forgot which example. I'm marking them off, and I forgot to mark a couple. So, oops. Okay. All right, same drill. I'm going to write up here. Please pause before you proceed, and let's compare notes and make sure that we agree on the first substitution step. I'm just picking these out of order, so it just is happenstance. It's coincidence that we've gotten 3 in a row where the minus has to switch, right? So your thought from here, I'm trying to get this stuck in there in your head, is that we got to look at the minus in front of the 4 and say, do you stay or do you switch? And again, he switches. So we make the -1 a +1, make the -4 a +4, and all's well. Now we just got to do some real low-level mathematics. What in the green box is 4 times 3 times 1? And what is 36 plus 12? Good. So now we're left with x equals a much cleaner looking answer, 6 plus or minus the square root of 48, all divided by 6. So we've seen the flavor first off where the root was just like dead. We saw the flavor where the root becomes a rational number and we do the pathways. And now we've seen the flavor where we can simplify a root. So while I answer this interrupting phone call, you guys can work this out. I just want to. So how do we break down a square? Oh, by the way, I should have asked. We know now that the next thing is to consider the root, right? So like when it was a 33, we were done. What do we do with a 48? Yeah, we're not rookies anymore. We don't say things like 4 times 12 or 8 times 6. We just know better. We know because we've memorized that 48 is 16 times 3. So we go off to the side or we do it in our heads. We know that the square root of 48 is the square root of 16 times the square root of 3, which becomes very good. And then we substitute that now back in. So where we're at in the process now is we have x equals 6 plus or minus 4 root 3. And we have one more consideration. What is it? The triangle. Remember, the triangle doesn't exist until someone breaks out of jail. And in this case, this 4, I'll point to him with a green arrow. 4 is like jackpot, baby. 4 broke out of jail and is now in play. So the triangle now exists around these 3 numbers. Are they all simultaneously divisible by anything? 2 is the best we're going to do. So that's going to give us our final answer that we'll put a box around. X equals 3. Jackpot. And we don't consider pathways here because we can't really perfectly evaluate like 3 plus. That's why we don't go further. The 2 root of 3 makes us like, oh, stop there. Okay. So good. I'm going to put a check mark next to that one so I don't. I'm going to make sure I do these in the same order in 5 hours as I'm doing them right now. So. Still good? You guys feel like really bored, like you're going to just all get 100% on this quiz? 100%? Okay. Right? 100? Because there might be a small mistake somewhere. That's, yeah. We're human. What do we do first? Yeah. You Beyonce that sucker to the left. So we got 4x squared and then what?
Minus 8x plus 2.
Now what do we do? Nope. I'm just telling you this because I care about you. And it's my job to do the best I can do. Instead of writing down A, B, and C, what could we do? You could reduce all the numbers by 2. And it's totally legal. There's no black magic happening here. Just like in 7th grade, when you learn that you can divide both sides of an equation, same thing. I'm dividing every one of the 4 terms by 2. The x squared, the x, the 6, the 0, everyone's getting divided by 2. And I choose this route because I'd rather work with smaller numbers. You will get the same answers if you use 4, -8, and 6 as I will, but I'll have less reducing to do. So now I'm ready. A is 2. What's B? C. Okay. Same game. Let's go again. All right. Where does our brain go now? I'm really just trying to, right. I'm trying to just get this trained and stuck. So yeah, do I switch the minus to a plus? Not this time. So there's no negative after it to make that happen. This is oftentimes what causes the I to come into play. So when I multiply the green box, what's 4 times 2? What's 8 times 3? So the math I'm actually doing inside of the square root sign is actually 16 minus 24. And what does that equal? -8. So now I have x equals 4 plus or minus the square root of -8, all divided by 4. So we're going down a new path here. This was the notes that we took Monday. All right. What do we do? How do you square root of -8? Nice job. So remember, the square root of -8 is the square root of 4 times the square root of 2 times the square root of -1. What does that become? So we take 2I root 2 and inject it back in place of the negative 8. So our new answer, not final by any means, but it's 4 plus or minus. And the triangle comes into play again. I'll draw it because that's just how I roll. Notice I'm not putting the I in the triangle. I'm trying to leave that out. Sometimes I get lazy and include it, but technically it's not really in there. So what can all the numbers in the triangle be hit by? 2. Resulting in a final presentable boxable answer that says x equals what?
2 plus or minus 5.
Done. Again, this problem is going to freak you out. And honestly, there's different ways to solve it, but for the theme of where we're at, it's gonna be a little odd. So let's ride it out. What do we do first? Move the 4x squared, and then everyone can follow him. It's all about that guy. He's the boss. And so the 4x squared is negative, and I'm like, nope, you're heading to the other side. And then the minus 4 is like, well, I guess I better come over there too. But if this helps you, don't forget that you can do that. And I wrote that in red just for your educational convenience, that 0x is a reminder that there is a b, we just don't see it. So what do we do? Could we? You tell me. Do you think we could divide all those numbers by something? I do. I was making that face at you to test your will. You should have put your foot down and said, heck yeah, Mr. Ahern, I can divide every number in this equation by 4. So let's go ahead and divide every number in this equation by 4. Why? Because smaller numbers are better. So if I divide everything in this equation by 4, because I can, this is going to become x squared plus 0x plus 1 equals 0. You should do that. I know that that's not something that we commonly talk about, but now that it's almost quiz day, like T minus 23 hours and 20 minutes, you should do that. Divide when you can. And so what's A? What's B? Nice. What is C? Okay, let's do this. Same drill. You write, don't look at the TV until you're ready to look up and say, how did I do? So you got this. These are the ones that can freak us out. Notice that it looks really different, and I don't have anything there because if b is 0, what's the point of putting -0? That's just creepy. And I don't have anything here because 0 squared is pointless. And so you've seen this before, that we just bypass all that and get this. So yours should match mine from this point on. There's really no conversation. I mean, I guess there could be. Does the -4 switch? Nah. So the overall, just what happens is inside the root, we just wind up with a number. So we have x equals the positive or negative of the square root of -4 all over 2. What do we do with a square root of -4? Got to use I. And the square root of 4 is 2. Yeah, nice job. So I'm going to replace that with just x equals the positive or negative of 2I over 2. And finally, You're right. There really isn't so much a triangle in this case as there is it's just one fraction. So you can just do straight old school reduction. See these twos, reduce them. They both become ones. So your final presentable boxable answer is x just equals positive or negative I.
But the negative I be like the negative.
No, it can't penetrate the root like that. So I would be the square root of -1, and negative I would be the negative of the square root of -1. But those negatives don't get to come in contact. The root blocks them. But just positive negative I is great. You guys still feeling good? Like you got this? Okay. I'm just boring everybody today, and I'm sorry for this. Pablo, look at how bored Pablo is. Pablo's just not having it today. You want to be outside kicking field goals, huh? Kicking footballs. I get that. I wonder if I could. You guys think I could kick a 20-yard field goal?
No.
That's fine. You're not going to hurt my field. I wonder if I could. I should try. I'm gonna come out sometime see if I could kick a 20-yarder. Do you think I can? Well, that was very harsh. Okay, you can try. Yes. Thanks a lot, Pablo. Let's go again. Just gonna keep hitting you with practice. Practice is good. I'm going to stop making you set it equal to 0. Okay, let's dispense with that. I'm just going to move everything to one side so we can just, but I won't do that on the quiz. But for today, it's like we get it. So we're good. Pablo, practica hoy después de escuela. Maybe today's my day. My knees aren't very good like they used to be, but I wonder if I can still. I wonder if I've never actually kicked a football through uprights before. I don't know if I can. I can kick a soccer ball, but I've never kicked a football through uprights. Josie, you think I can kick a 20-yarder? All right. Challenge accepted. My goal is by November 1st to be able to routinely, with high percentage, be able to kick a 25-yard field goal. Now, if I kick a 25-yard field goal, that means that the ball is spotted at the 15, right? Because I need 10 to get through the end zone. So from the 15-yard line to the goal, to the post, that's a 25-yarder. All right. Challenge. I can't kick a 50-yard field goal, Gavin. I don't think you could either. In fact, I'd be. So we're still in quadratic formula mode. So there's no division here. A is 1. B is -2. C is -19. So same as before. Here we go. Do you guys match? Do we match? Where does our brain go? Yeah. So we just look at that minus sign. This minus that I'm turning white right now has got to be your focus. If you want to get an A, that's just where you go. You think, and then you look later, you're like, hey, there's a negative. I'll switch you both to positives. Done. And so what is 4 times 1 times 19? And what is 4 plus 76? Nice. '80 is one of those poop numbers. I know as a math teacher that it's hard for students to spot 80. So you got to just know from experience or put it in your notes, what's the proper breakdown for an 80? 16 and 5. Remember, when we were rookies, we would have said things like 8 and 10 and 4 and 20. We're not rookies. So 16 and 5 is jackpot. So I head out and I break it into root 16, root 5, which becomes 4 root 5. And then I re-inject that into my answer. So my answer now currently sits at x equals 2 plus or minus 4 root 5. Triangle. What can I divide them all by? What will it say? You know, I got really lucky just now. I will say again, out of all these problems that I just randomly have just been picking them, I'm really happy with the spread we've gotten so far. It's like, this is working well. This is a great mistake that you made. And I'm really, it sounds weird, but I'm glad you made it. Normally, when things divide out to make ones, we just get rid of them, right? We cannot get rid of this one. He's what we call a placeholder. So when that one divides out to become a 1, you have to keep him because he holds an entire structural piece of the puzzle together. If there's a 1 in front of the root, who cares? If there's a 1 at the bottom, who cares? But the one that I'm pointing to with that white arrow, he matters. So this is 1 plus or minus 2 root 5. Got that? Good? Okay. Have you guys had enough, or do you want, we can do more? I got more. Good. I guess I'll cut this off. I've got more problems. If anyone would like to practice some more, I don't know what they all have to offer. I just was like a grab bag, just picking them. So I'm going to cut the recording and I'll cut you loose. Not, you can't leave, but make sure you have a good page of notes. Make sure that you bring your calculator tomorrow, not your cell phone. That's it. It's a nice day for a quiz. The Thursday quizzes are the best.
I really like